Okay, this is lesson on solving equations with variables on both sides, infinite and no solution, and infinite and identity. Um, we will be looking at some of the similar things that we talked about in class on Tuesday. It goes along with lesson 3.3 in your textbook, so if you want to find that, you could. We're going to solve algebraic equations with variables on both sides. Okay? We had talked about yesterday about moving the variables to the equal sign. That's what we're going to be doing today. We want to get the variables on one side and the numbers on the other so we can solve in terms of. Okay, so here's one like we did yesterday. 7x plus 19 equals negative 2x plus 55. Okay, so we want to get the x's on one side and the numbers on the other. And we talked yesterday about how we might like the x's to be on the left side. And so if we're going to do that, it would mean that we would need to do the inverse operation of the 2x. Okay, we're going to bring it through the equal sign to the other side. And in doing that, we need to inverse or add 2x. So I would add 2x to the like terms. Our terms have to be alike. And when I do this, those would cancel out. Then I'd be left with 9x plus 19 equals 55. And now I have a standard two-step equation. So I would subtract 19 from both sides, and I would get 9x equals 36, and then I would divide both sides by 9, and I would find that x would equal 4. And I could substitute it back in and have 28 plus 19 should equal negative 8 plus 55. Okay? Just a standard equation with variables on both sides. Moving on to B. Solve 80 minus 9y equals 6y. Well, in this particular case, we already have y isolated by itself. So we should bring this y, remember the sign in front stays with the number, to the other side. So I would need to add 9y and add 9y. So 80 equals 15y. Some of you don't like to have the variable on the right side, so you could write it 15y equals 80. Either way, we're going to divide both sides by 15 and find that y would equal 6. Okay? Different examples for you to have in your handy-dandy notebook on solving equations with variables on both sides. Let's look at C and D. C, what do we need to do first? We need to distribute. So 3 times x is 3x plus 3 times 2 is 6 equals 3x plus 6. Maybe you noticed something. Both expressions, 3x plus 6, 3x plus 6, are the same. I'm going to walk you through the solution part of this, and let's see what we end up with. So if I subtract 3 here, because it's positive, bring it through, and I subtract 3 here, that cancels. Oh my goodness, this cancels, so I'm left with the fact that 6 equals 6. What that means is no matter what number I put in for x, it's going to make the equation true. So there are infinite solutions. Okay, let me show you. Let's say x equals negative 2. So we have 3 times negative 2 plus 2 equals 3 times negative 2 plus 6. Okay? Negative 2 plus 2, 0. 3 times 0, 0. Net 3 times negative 2, negative 6. Plus 6, 0. Okay? Let's pick a positive number just in case you don't think it's true. Let's say x is 4. Here we go. Let's substitute. 3 times 4 plus 4. Oh, sorry, my bad. 3 times 4 plus 2 equals 3 times 4 plus 6. 3 times 6 equals 12 plus 6. 3 times 6 is 18. 12 plus 6 is, oh my goodness, 18. Okay? Infinite number of solutions. No matter what number I choose, my equation is going to be true, no matter what value for x I choose. X plus 2 equals x minus 4. Okay? Well, this is a 1x and a 1x. Let's go ahead and subtract 1x. These will cancel out here. Uh-oh, they're also going to cancel out here. So I'm left with 2 equals negative 4. Well, is that true? Does 2 equal negative 4? No, not last time I checked. So since those are not equal, this is a no solution, which means no matter what number I put in for x, it's not going to make it true. I can't find one. Let me show you. What if x is 5? 5 plus 2 equals 5 minus 4. 5 plus 2 is 7. 5 minus 4 is 1. 7 does not equal 1. Let's pick a negative number. Negative 3. Negative 3 plus 2 equals negative 3 minus 4. Negative 1 equals negative 7. That's not true. So when you have where a value of a number equals a different number, there's no solution to that. Nothing we put in is going to make that true. Okay? These are the different types of equations that you can have with solving with variables on both sides. Let's look at E. Let's distribute. 4 minus 4x plus 3x equals negative 2x plus 1. Oh, my bad. 2. Okay? Combine like terms. Can't take 4 minus 4x, so I look at negative 4x plus 3x. That becomes 4 minus 1x equals negative 2x plus 2. Negative 2. Sorry, my bad again. Okay? We want to bring x over here. So I want to add 2x, add 2x. Those x's will cancel. 4 plus x equals negative 2. Subtract 4. X equals negative 6. So if we were to substitute negative 6 back into the equation, we would get the same value on both sides. Okay? One more. This one has a fraction. Okay? Let's start with this. Let's just distribute, okay? So 20. Or do you want to multiply the whole thing? Now let's distribute. 20 minus 10x plus 4x equals negative 3/10 x plus negative 3/10 times 3, negative 9/10. Okay? Now, you could do one of two things. You could turn these into decimals, or we could multiply and get rid of the fraction. You want to turn them into decimals? 3/10 is 0.3x plus negative 9/10 is 0.9. So 20 minus 10x plus 4x. If you would have multiplied through by 10, So now I have a decimal. I can leave it in decimal form or I can multiply through to get rid of the decimals. Let's multiply through to get rid of the decimals. Whether you multiply through to get rid of the decimals or you multiply through to get rid of the fractions, you would have ended up with 200 minus 100x plus 40x equals 3x plus negative 9. Combine like terms. Can't do these two, but I can do these two. But this is negative, so it's 200, negative 100 plus 40, negative 60x equals 3x plus negative 9. Add 9 to both sides. And we have 209 minus 60x equals 3x, okay, plus 60 plus 60, 209, oops, I think I made an error, this should be negative, didn't I? Yep, my bad, trying to do this quickly, left it off there. Going to equal 57x. Okay, so now I have 209 equals negative 50, I'm sorry, positive 57x. Oh my goodness. So divide by 57. And I think you're going to find out that it does not come evenly. Okay? So 57 times 4, 20. It's too big, so it's 3 times. 57 times 3, 171. So it'll go 3 times. And you're saying, well, Mrs. Rice, it's this. Okay? So what do we need? I don't want that. That's a repeating decimal. 6/10 repeating is the same as what fraction? It's best to leave it as a fraction. 3 2/3, or I would have even accepted 11/3, because this, even though it's improper, is in simplest form. Okay? You may go back to the class and begin working on your guided practice, which is at the bottom of your notes.